Thanks. Greg, is this on? Yeah, it is. Okay. I've been involved in a program called Grain and Graze for the last 15 years. It's a mixed farming program, and in that mixed farming program we've done an awful lot of work around grazing crops. I'm going to try and give you a snapshot of some of those key findings out of that, but I'm really happy to talk about anything related to grazing crops, crop integration, crop rotations, that sort of stuff. So in trying to put this presentation together, I wasn't quite sure just exactly what territory people wanted to cover. So please feel free, if you want to sing out and ask any questions, anything related to that sort of stuff, then I'm happy to try and answer it. Just out of curiosity, how many people are grazing crops? How many of you are also trying to take it through for grain, of those that are grazing those crops? Not many? Sort of? Sort of, okay. Because a bit of the stuff that I've got here is around grain yield and how we can try and manage grain yield as well as getting the grazing out of those crops. So I might change this presentation midstream if we want to talk more about just how do you maximise production out of the grazing of those crops. Okay, but we'll start off with a few things. Oh, by the way, has anybody grazed the stubbles out of their crops? Couple? Not many? Okay, all right. So this presentation, I'm not quite sure then exactly how the fit will be. So, as I said, sing out if there's other stuff that you want to know, because they also asked me to put some stuff in around grazing stubbles as well. Anyway, just as a bit of background, if I think about the mixed farming system and where we can actually get our different feed sources from, we've got the obvious ones of grazing winter crops, and those winter crops I'll include both our cereal crops, so wheat, barley, oats, triticale, that sort of thing, and also canola in that as well. So that is certainly one feed source that we've got and one opportunity that we've got. Second one is grazing the stubbles, which mightn't be relevant to as many people, particularly if you've got cattle as opposed to the sheep, but we've learned a bit around those grazing of the stubbles. The third one is about using some fodders in a short-term phase in a rotation, which might have a bit more relevance, so we might spend a bit more time on that one. So they're things like short-term ryegrasses, clovers, those sort of things as part of a rotation to actually boost winter feed production. And the last one, which is a novel one, which I'll chuck in, but for most of you probably wouldn't be in the way of using it, is to sow some crops that we've got now that have what's called a strong vernalisational winter habit. We can sow them in springtime, we can use them as a fodder over summer, and then we can take them through for grain in winter. And so some of these brassicas, like this one here, this is actually canola, this one on the right hand side here, sown in about September, October, grazed as you would graze any fodder, typical sort of brassica fodder over summer, locked up, and then take that through and you'll get 2 or 3 tonne of canola grain off it as well. So they're the 4 different feed sources. Challenge with that is they produce feed at different times a year. And so somehow in our management of that whole system, we have to try and put those different feed sources together. And as you would probably know, and the little graph at the bottom is really just an explanation of that, most of us typically have to cope with a feed supply, which is that orange line there that fluctuates like that. So as we know, grows heaps in springtime. Depending on when we get the autumn break, we have nothing around that Jan-Feb until we get that break, and usually dips down a bit, slower growth in middle of winter. And the black line generally represents, and this is for a self-replacing herd, but anybody that's in that reproductive sort of game will realise that while we can vary our feed demand, the amount of animals that we've got on, it doesn't vary anywhere near as much as what our feed supply does. And so our big challenge is how do you cope with when you've got an animal demand that you think might change a lot, but in fact is fairly flat, compared to a feed supply which jumps up and down and is quite variable just depending on the way the season pans out. So, first thing I just want to talk about briefly around the summer crops. Now, if anybody's got interest in the summer crops and, the winter crops and some of the information in it, there's a book on the Grain and Graze website called Grazing Cropped Lands. So a whole lot of information that I'll just touch on here is actually in that booklet. It's about a 60, 70 page booklet. Unfortunately, we don't have any hard copies left, but it's got all really the research for the last 15 years all summarised in it. If we look at just the dry matter that we get from our grazing crops, now just to explain this graph, and I might jump onto that one as well, and it's not necessarily all that easy to read. What I've got up here is the amount of dry matter that's been produced, and along here is the time since sowing. Now, we've run these trials over about a 15-year period, so there's about 150, 160 replicated trials in here where we've measured the quantity of dry matter that we've produced so many weeks after sowing. So the first 3 relate to wheat, the second 3 over here relate to barley. Now, these are called box plot or box and whisker graphs. The dot in the middle represents the average, which is that number there. The box represents 50% of the results in that range, and those whiskers or those lines represent the highest result we got and the lowest result we got. Now, the reason why I put this up out of those hundreds of trials, because I could have selected anything to prove whatever I wanted, bottom line is it's highly variable. So while you're growing these crops and you think they'll add to a feed source, you've got to snag the right timing, particularly of your autumn break, to get the sort of feed that we need. So, for example, barley, wheat here, 12 weeks after sowing, we had in some results here nearly 3.5 tonne of feed, three months after sowing. You know, that's an enormous amount of feed. In the same period where we got a very dry period, we were down only a few hundred kilos because we didn't get the break and we didn't get the follow-up. Reason why I put this in is a lot of people think that the panacea of having feed in winter is to put some of these winter crops in. You just got to realise that there is a risk associated with it, okay? And you can't bank on it every year. And unfortunately, the year when we really want the feed is usually the year when your crops will be doing this as well. So feed will be tight. Years like this where we're performing really well and we get phenomenal amounts of feed, usually it's an early break, it's probably been a bit warmer, I bet you all your pastures are growing pretty well as well. So the value of that feed is different as you get further into the year. Yep.
When you've got barley, say 9 weeks out or 6 weeks out in sowing,
yep.
That would be sowing 5 weeks sowing dry and then 2 or 3 weeks until it's run.
Yes.
And only 3 weeks old.
Yeah, it could be. For most of these, though, they will have germinated and you will have got a shot and then they will have stopped. And in some cases, we've seen them and you think, oh, they're going to die. There isn't enough moisture there, enough moisture to germinate them, but then they've just sat there until they've got the next bit of rain. No, above about 450 is what we call the high rainfall. So I should say all these low and medium have come from the Wimmera Mallee and places like that as well in Western Australia. So this is Australia-wide, this stuff, yeah.
Yeah, just to check, did others hear those questions put to camp? Do you want them repeated?
Okay, I'll repeat them in future, Greg. Yeah.
Yeah, just to make sure.
Okay. Yeah. And I think probably the other message just to take out of that, at about the same period, barley is giving us higher growth than what the wheats are. Okay, and these include both winter and spring wheats. That's the first one. Second one around the dry matter. Some people would probably be familiar with what is commonly called the MLA pasture ruler. People familiar with that, where it's got a little ruler up the side and it's got so many centimetres and kilograms of dry matter. We've got a similar scale that we can use to estimate the quantity of dry matter in a crop. So that's what those two tables are there. So if a crop's at about 10 centimetres, it's a cereal crop, it'll have about 500 kilos of dry matter in it. Okay, there's a few caveats down the bottom there about how row spacing and establishment and stuff like that, but it's a different scale to what you use for your pastures. Okay, and if you were grazing canola, which most people probably won't be, similar sort of thing. Okay, so the message there is just it's a different scale, which you'll be able to find on the Grain and Graze website. All right, a little bit on the quality of all those feeds. This is a summary of hundreds and hundreds of feed test samples that we've taken, and I've just broken them up into early vegetative, late vegetative and stem elongation. So early vegetative, when the plant's basically germinated and it's got leaf and no stem on it, so that'd be the first 6-8 week sort of period. Late vegetative stage is before it hits a thing called growth stage 30, which is where the ear that's in the bottom of the plant, the cereal plant, starts to move up through the plant. Okay, so that's that late vegetative period, and then the last bit we've got here is stem elongation, which is where the ear, the embryonic ear that's sitting in the base of the plant, starts moving up through the plant itself. So it starts getting stemmy, if you like. Usually occurs around about that August-September time. Now up here I've got the amount of energy and the amount of protein. So if we just take the energy one first, the red line I put on there is typically what our pastures would be at the same time of year. So these are well above what your pastures would be as far as quality goes. Okay, at least another megajoule higher in energy, and even in that stem elongation phase, well above where your pastures will be. And the same with protein in that early stages there, that they're around about that 25 to 30% protein. And most animals probably need 16% max if they're lactating or growing quickly. Most of them need less than that. So basically it's rocket fuel that we're putting down their throat. Now, in all the livestock or the animal measurements that we've done over these crops over numerous years, we've discovered a few animal health type issues. Because with that sort of rocket fuel going down their throat, you'd expect performance to be better than what we've found in a number of cases. And a few things that are worth touching on. First one is around a mineral imbalance. All your cereals in particular are low in magnesium. Okay, most grasses are low in magnesium, but cereals, actively growing, fast-growing cereals are low in magnesium. And they're exacerbated by cereals which quite often have a higher concentration of potassium than they have of sodium. And so we can get really poor animal performance because we run into a magnesium deficiency grazing those crops. So after a lot of work, a fellow by the name of Hugh Dove at the CSIRO came up with this very simple loose lick, which is a salt lick of equal parts of coarse mag, limestone and salt. Just put it out in the paddock when they're grazing. This is for sheep and for cattle, and they will just ad lib just lick that when they need that salt lick, and that will fix up that imbalance. And for cattle, he was getting over a kilo difference in live weight gain of whether they had access to that mineral or not. Very simple thing to do, very easy to mix up. Don't have to buy fancy blocks. Just buy a few bags of stuff and mix it up yourself and put it in a drench drum. Cut off drench drum and you're in business. The second one that people may have experienced is issues around fibre. A lot of these cereals, particularly in these earlier stages here, have low fibre. Now, I'm assuming people are familiar with the term NDF, or neutral detergent fibre. It's a test that is done to work at how much of the digestible fibre is in a feed that an animal's eating. While there aren't any standards, from a dairy point of view, most of the recommendations are around about at least 35% fibre that you want in your diet. A lot of these cereals, in average in this stage here, is around about 39 to 40%, but we did measure a number of cereals that were below that 35%. And I think some people, if you've grazed cereal crops, you'll see that the feed tends to run through them fairly quickly. Fibre can be one of those issues. So where we've found some of those animal health problems have been because we simply don't have enough fibre in the diet. So simply putting fibre out there in the form of hay or something like that that they can eat will help overcome that problem. Yep. Yep.
Just with the mineral leak that you put out, I worry sometimes if I run out for a few days or a week, they'll make the problem worse. Is that fair to say?
Yes, yeah. So it's if it runs out and therefore they're not getting access to it every day. Yeah. No, there's an accumulation of it in the animal. So missing a few days like that, no, isn't a problem. So we've had loose licks that we only checked once a week. And you'd come back and it was missing, but you'd put it back in again and their weight gains were still fine. Yeah, it's just that particularly if they're on there for a period of time, 4 or 6 week sort of period, where they start on one crop, might graze it for a couple of weeks, then move on to another crop, move on to another crop, they potentially can end up with this magnesium deficiency because they've been grazing too long on low magnesium single source feed basically, which you get from some of these high growing or fast growing cereals. Okay, the third one I'll just touch on, and this is one that's still a bit of a mystery to us. Occasionally we've encountered problems where everything looks right, we give them minerals, we give them fibre, and they still don't perform. And this is one example. I don't know if you can see that that bull calf there. He's got a little accelerometer on it, a little harness on them. So on there we were able to, the 70 in this trial that we did, we're able to work out just exactly how many times they ate the crop, how many bites they took during the day, how many times they regurgitated their cud, where they walked around, all of that sort of stuff. So we could tell very precisely every animal exactly how much they ate over an 8-week period when they were grazing different crops. And these are the results we got. Now, just to explain the 4 periods, period 1 is pasture, period 2 is when they went onto a wheat crop, period 3 is a barley crop, and period 4 is when they went back onto a pasture again. Up here is their weight gain. Okay, so when they were on pasture, they were gaining about 1.6 kilos a day, and that pasture was 26% protein, 11 megajoules of energy. Went on to the wheat crop, that dropped down significantly compared to where they were when they went on to the barley crop. So this is about, they had about 2 weeks, 2.5 weeks in there, 2.5 weeks in there, 2.5 weeks in there, and then 2.5 weeks back onto pasture again. And you can see the dramatic difference in the live weight gain of those animals, all under very strict curfew when they were weighed and all that sort of stuff. And there was something of them eating the barley that they just didn't like, fast, high-growing barley. And this here is their access, daily visits to the licks and to the straw. So those 2 things that we suggested to actually put out for them to improve that performance, you can see here in period 3 when they were on the barley, they just didn't like what they were eating. So they went back to the straw in cases here, 10, 12 times to eat the straw. Even though all the things that we tested, the natural, or the tests that we could do easily, all were pointing that there shouldn't be anything wrong with it. So I reckon there's still, and I'll put this out as a bit of a warning, while 99 or 90% of the time we'll get the response we want from our grazing crops, occasionally you get these odd responses. And it appears to be on the very actively growing, very lush pastures, high nitrogen type systems. So these barley crops were growing like mad at the time when the animals went on there. Even though they had fibre and things like that, they just didn't perform. We took a whole lot of blood tests. There's been a whole lot of analysis done that on nitrate and other bits in the blood. We still haven't got to the bottom of it yet. So it's just a little bit of a warning, I suppose, in this grazing crops that occasionally you won't get the results you expect to get. Okay, I'll skip over this really quickly for anybody that's interested in the grain yield of the 100-odd replicated trials that we did. In about a third of situations we improved grain yield. So this is a graph of just showing our change in grain yield due to grazing. So it's a comparison where we grazed the crop and another area where we didn't graze the crop, and we could compare the yields at the end of the day. We found most commonly that we lost a little bit of grain yield if we grazed those crops compared to if we didn't, and so this is wheat, barley, oats and trip, all 4 of those are in there. In some cases we improved grain yield, and that was more than anything else because we removed disease out of that crop. So in that vegetative canopy, eating that off with the animals actually improved the yield of that crop. But in most cases we lost some yield, and we lost some yield, quite heavy yield losses down here, because we grazed incorrectly. So we grazed too late when the embryonic here, particularly that plant, was coming out the head. And so we took that off and therefore lost yield as a result. Not sure if I'll go through that, because this is really about our recommendations of grazing our winter crops. I suppose just the key things out of that is that in grazing winter crops, my suggestion would be that you sow earlier. If you're going to put any of these winter crops in, you sow earlier rather than sowing later. Because if you are interested in reducing grain yield loss, then the key thing is the time from when you finish grazing to when the plant flowers, or anthesis. So it's the ability of that crop to recover from when you finish grazing to when it's ready to flower dictates whether you'll lose grain yield or not. So you can graze it really hard, but then if you put nitrogen on after it and it's got a good period to recover before it flowers, then you won't lose grain yield. If you graze it either too hard or graze it too late and the plant can't recover, can't regrow that leaf before it hits the trigger of flowering in that plant, then you'll lose yield because it just doesn't have the energy that it's got in its leaves and its stem to fill that grain, the potential in that, the grain in that plant. So I think that's the main one. Okay, I'll flick over the grazing stubble one pretty quickly. In a nutshell, stubbles ain't stubbles. There's some grazing value in stubbles, and if anybody's at the sheep one tomorrow, I'll go through some of the summer weeds and the grazing value of some of those summer weeds that you think are probably worth nothing. In fact, they're worth a hell of a lot to you. And we find that in stubbles as well, that in fact if there's green or there's grain in a stubble, it's extremely valuable. We haven't done much work on cattle, but with sheep, there is a really repeatable point where those animals will either gain weight or lose weight when they're grazing a stubble. And it's around about, I've got here 13 grains in 0.1 of a square metre. So 0.1 of a square metre is about, if you put your boots at 90 degrees to each other, your boots are about 30 odd centimetres long, that's about 0.1 of a square metre. So if you draw a little square like that, if you can count 13 grains within in that area, then I can tell you for sheep, they'll go around and pick up enough of that to gain weight on it. Okay, as far as green pick goes, if you can count 14 green shoots, so they can be weeds, they can be any sort of weeds, they can be cereal left over and stuff like that. If you've got any of those green shoots, that's equivalent to about 40 kilograms of green. 13 grains is equivalent to about 40 kilograms of green as well, on the ground. Both of those animals will gain weight. As soon as you drop below either of those thresholds, animals will lose weight. And it is a real roller coaster. So they'll gain weight until they hit that threshold and then they crash. They don't run flat. So if animals are ever grazing stubbles, they don't sit on the same weight. They will go up really, really quickly and they'll go down really, really quickly. Take them out after the end of 5 weeks and they're the same weight you went in and you think they've just stayed the same. They haven't. They've been on a real roller coaster. That's equivalent for pulses, but most of you guys aren't probably croppers. That won't mean much to you. That's what 40 kilos of green looks like. So a little bit of green pick. So if you can imagine, that might be a few weeds, that might be a bit of dandelion, it might be a bit of goosefoot, it might be a bit of milk thistle or something that's growing there. You only need a little bit of green pick like that and that'll be enough for animals to gain weight on it. Okay, is anybody interested in the economics side of it? Because I'll go through it quickly because it's on the slides, but when we tried to put the economics around all this grazing crop stuff, the simple way of doing it is just saying we grow this amount of dry matter. So we sow it, we grow 1,000 kilos of dry matter. If I had to feed that in grain, what's it worth to me? Okay, and it's a simple way of looking at one, a substitute basically of one sort of feed source to the other. But in most cases with our grazing crops, it's not the way it works. In fact, the way it works is that we'll get a change in grain yield, which for some people becomes important. We'll get a benefit from not only grazing that crop that we think we're substituting, but you actually spell your other pastures. And the value of spelling that other pasture, keeping that leaf area on it without an animal grazing it, is worth a hell of a lot. And somehow we need to capture that value. If we've got higher condition on those animals when they come up off that crop, it's not only just a substitute feed that you've got, it means that they go onto higher quality feed in higher condition and it flows through into things like wool cut, lambing percentage, improved growth of your younger animals because the females milk better. Importantly, less supplementary feeding because the condition's better on them. And an important one is that it's got less value in years of abundance. So when we're having a really good year, grazing crops, or the value of our grazing crops, is worth far less to us because we've got feed everywhere. And so taking all of those sort of things into account, it's pretty challenging of how you actually work out what the grazing value is. We did some modelling on this sort of stuff to try and pick up all of those differences and all those different points. This was a property at Inverleigh in Victoria. Now it's a cropping property that's got 900 hectares of grazing. Now it's all sheep in this example here and 240 hectares of crop, wheat, barley and canola that's being sown. And I'll jump to the chase on this one. This is the result as far as the profitability goes. So the dot in the middle represents the average over that 28-year period, which is about $10,000 a year, or for this farm about 2.3% increase in profit for being able to graze those crops. In the best year it was about 10%, and that would have been a year where the crops have contributed an awful amount to the value of the feed that was available, and livestock were probably worth a lot and crops probably weren't worth much, so we could lose a bit of yield and it didn't matter. But in some years, it actually cost us money when we were grazing those crops. So the story I want to get you to take away is that it's not all beer and skittles. It's not always easy. We put a bit in, we graze a bit of crop, it's going to make you money. It doesn't always do that. Only does it sometimes. But the key message out of the whole thing is if we can sow earlier and try and capture that early growth out of those crops, we can make quite a big difference. So that previous one was just being sown at the traditional sowing time. You'd sow your crops, which usually is around about late April, early May. This is bringing it to the start of April, so only 3 or 4 weeks earlier. And in this case here, our average profit's gone up to about $29,000 where it was about 10,000 before. Our best profit now is about 15% or 67 grand as opposed to 34,000, so there's a big upside in that. And our losses or our downside risk is about the same. So I'd encourage you, if you're grazing crops, get them in early. The real value of them in all the work that we've done is being able to sow them early, even if you sow them dry and you look to graze them earlier on in the piece and take the punt on sowing them dry. That's where you'll get more value than if you wait for that traditional sowing time and then wait for that traditional sort of late, I won't graze it till I've got 2 tonne of feed in front of me before I put the animals in. You get far less value out of than if you're grazing early. I was asked as part of the talk something a bit random, as how can we use crops to help in our pasture improvement or in a pasture improvement cycle. I'll just pull out a little bit of work, and it's mainly around the weed side of it, because I've got a few clients and we do use crops in a, if you like, a short-term rotation to help improve the quality of, or the preparation before we sow back into pasture. So we've got a weedy pasture that's basically it's done its life. How could we use crops in a short-term type rotation to help prepare before we sow down our pastures again? And the key message to come out of it is this graph here. Now this is actually taken from a book called Pastures in Southwest Victoria, but the message of it is the main message out of using crops as a cleanup. Out here I've got different species, along here I've got years. The thickness of the bars refers to the viability of the seed of those plants. Okay, so something that's got starts quite thick and goes narrow after 1 year and after 2 years peters out, like we've got here for our barley grass. That means that basically if we can stop seed set of that plant for 2 years, we will clean that up really, really effectively. Okay, and so for things like capeweed, if we can get a 3-year cycle out of that, we can clean them up really effectively. And so all of these down here, which you'd probably be familiar with, which are common weeds in pastures that we get, using crops in a short-term rotation and achieving seed set control can be really valuable. We've got other weeds though, and if we just look at the one here, goosefoot here, sorry, not goosefoot, wild radish, 6, 7, 8 years later you can still have seed that was set 8 years ago that will germinate 8 years later and come back in your pasture. And these were some trials that we did in Southwest Victoria, where we looked at controlling annual ryegrass. So these are the annual ryegrass numbers up here. We put grazing oats in for a period, so we used grazing oats as a fodder to clean up those weed seeds as best we could. And so even after 1 year, we had this dramatic reduction in the amount of annual ryegrass that carried over into the second year of the crop. And depending on what we did in subsequent years, depending on what we did in subsequent years, we were able to keep those ryegrass numbers to fairly low levels. If you contrast that with something like wild radish, which was one of those that's got a lot of seed carryover, while we reduced it in the first year, by year 3, all of those numbers were going back up again. So we weren't able to actually use it to clean up our crops because we had seed that was set 5, 6, 7 years ago that was just waiting to germinate. So if we're using crops as part of a pasture preparation program, we've got to understand what weeds we're trying to deal with, because some weeds it'll work really effectively and other weeds it won't. How much time have I got, Greg? 30 minutes, so what, a couple more minutes?
No, not 30. We've got 8 minutes, we'll have 5 minutes.
Okay. Okay. All right, I'll just finish off on this one. which is around the summer fodders, which I mentioned briefly at the start. In recent years, a number of the brassica crops that we've got, particularly canola, has now had bred into it a thing called winter habit. And winter habit basically is a cold period that the plant needs to experience before it will go from vegetative to reproductive. It's come out of the northern hemisphere where it goes under snow for a period of time, so those plants aren't trying to grow when they go under those really cold conditions, and they only come out and start growing again. So they're sown before it snows, they get snow on top of them, they'll come out the other end when conditions are warming up. So they've gone through that cold period, they hit a warm period going into it, and then they will go through and do their typical growth and then reproductive phase and run to seed. We've now got, as I said, bred into some of our annual brassica fodders, and so this is canola that these animals are grazing here, which means we can sow them in springtime when temperatures are quite high, and they will go all through summer, and they will go into autumn, and they will go through, and until they experience that cold period in winter, they won't flower and run up to head. So we're using these quite a bit now in a cropping rotation to sow in September, October. Use them as a summer fodder crop, as an alternative to any brassica that you might sow, a rape or a turnip or a pasture or something like that. Yeah, it can be an issue. It's better if they're established early though. We tend to find, as opposed to trying to establish them sort of December sort of period. So the question was about insect and disease. Green bridge for that is also a bit of an issue coming into it. But we've found we can graze these crops, get anywhere up to about 4 tonne of dry matter off them. And then if we lock them up and put nitrogen on at the right time, we will get yields equivalent to what we might get if we just sown traditionally in April, May. So we've actually got that fodder out of them, and then we can take them through for grain. I've got 0 to 4 tonne of dry matter. Obviously, if we get a really dry summer, then you've got that issue of the plants establishing but not actually producing much for you. They still will go through. If the plants don't actually die out, they'll go through for grain as well, but your dry matter production can be a fair bit less. I've covered that one, equivalent grain yield. I've got they're unclear on pests and diseases, so the pests are a bit sporadic about how we get that, and it's really as much environmental conditions as anything else. We can get some viruses carry through. That is one of the bit of downsides, but no different to if we were just sowing a summer fodder anyway. You're exposed to the same sort of issues as far as that goes. So just in summary, feed source in a mixed farming operation is more variable than just straight pasture, and I think this is one of the challenges I've had in the 15, 20 years working in the game. Is we've got all these different feed sources coming in at different times. How do you actually try and use them to your greatest advantage for when the animals actually need it? And so there is a bit more skill that's required in getting that right, and a level of complexity that means the decisions that you've got to make around it do become a little bit harder. We're not just looking at a pasture feed curve, you've got all these different feeds coming in at different times that can be of different value, and in some cases do have some animal health issues that we need to be aware of, because you can actually go backwards rather than go forwards with them. And I'll just finish off with I suppose a bit of a plug for a new tool that will be coming out relatively soon, be publicly available. This was a tool we've created to try and help understand how, when we've got all these different mixed feed sources there, how we can actually understand what it means from a feed supply and an animal demand point of view. It's called Farm Options, and in Farm Options you basically create a rotation on your farm for different soil types that you've got, and different water holding capacities. It runs a weather or a climatic thing for your local area. So if you were from Bendigo, you'd put the Bendigo rainfall and the Bendigo evaporation and stuff in, and you're able to build your own system, your own rotation. So, okay, I won't need 10 minutes to finish this off, Greg. Of things like, so we've got perennial ryegrass on some of it, we grow annual pastures on some of it, and in this case here we've got some rotations of in this case, canola, wheat, barley and stubbles as well. And we've got choices out here that we can just drop and drag these different ones in to look at different rotations at different times. In each of them we can put in things about how much of that annual pasture or that unit that we've got there can be grazed. We can put in things like feed quality in there as well, and we can put in pasture growth rates, so we can mimic the pasture growth rate to suit exactly what your farm system does. And then it produces these feed supply and animal demand curves. So we can include things like stubbles as part of our grazing if we want to. We can include our traditional pastures. We can include grazing crops. We can include summer fodders. We can put all of those different feeds in and just drop and drag them into this system, and it allows us to look at or calculate what that total feed supply is, and we put an animal one in there as well, and so we can get the animal demand in that. And yeah, it's called Farm Options, and now I've gone back to the start. Yeah, it's everybody can repeat what I've just said. It's called Farm Options. It'll be available relatively soon. MLA are supporting us at the moment to roll that out, so we've got 3 groups running with it at the moment. We're finding it's a really useful tool to get your heads around just how much feed do I have, when do I need feed, when do the animals have different demands on that feed. And it's simpler than grass grow. Yeah. Yes. Yeah. So the question was, is it like grass grow? Grass grow is a computer program that takes a whole lot of things into account: weather, soils, management systems, pasture types, and all that stuff. It's a simplified version of it, but uses grass grow, Graz feed, and Apsim, which is the crop equivalent, to do these calculations.
So it'll be able to model like barley or oats.
Yep. Yes. Yeah, and it allows you, if I flick back to this one here, if the pattern isn't quite right, we can adjust that up to get the pattern right. Yep. Yeah, you just change your... So you would have, in one of these options here, let's say you might have annual pasture plus lucerne or something. Yep. So you can combine those two in there, change the quality of the feed, change the growth each month of what you get, and it will then reflect those different types of systems you've got. This is what it looks like. So there's lots of reports that you get out, but this is one of the reports on feed supply and animal demand. So the blue bars there are what the animals need to eat. The white bars there is the variability in the pasture growth that you're going to get in that period of time. The green's the fresh feed you're growing. The orange is the fresh feed plus bits left over of the carryover feed from previous months that you've grown. And one of the reports that you can get out of that is when we have it's called livestock energy balance, when we've got animals demanding more energy than we've actually got feed available for us. And it allows you to kick into that, and you can then start playing around things like, what if I started grazing the stubbles, what difference would it make? Because it opens up the stubbles for grazing and so on. So I think it's going to be a really useful tool for us to try and understand the complexity of all those different feed sources. Even work well, I reckon, from a pasture situation. I think MLA's, people are familiar with MLA's feed supply animal demand calculator. I think it's a step on from that. And it's a step on from that because it models each year. So it'll model a good year and a bad year, and you understand the variability or risk in it, where the MLA one just gives you one average result, and it doesn't actually tell you what risk you've got hanging out there in good years and bad years, where this does. So that was just a bit of a heads up. Now, I'm not sure if any of that covers what people's expectations were when they walked into the tent. So I'll give myself a bit of time, Greg, to take any questions if people might have them. And I'm happy to take anything around grazing crop stuff, and I'll have a crack at answering it.
So we've got 5 minutes before we shift into the next sessions. So any questions coming your way?
Yeah, absolutely. I'll kick off again.
Yep.
What information do you have? Perhaps more sheds, I believe you use young cattle as well. Grow a oats crop, some clover or something underneath it, waiting to November with rescue feed, drop stock, and mature overgrowth.
As used. Okay, repeat. Okay, what about basically growing a crop and then using it almost like as a standing hay? later on in the year. Yeah, a couple of things I'd say, but that's used, I wouldn't say widely, but it's used in Western Australia quite a bit, and in some cases they actually mow it to retain that quality. So the biggest issue you've got there is retaining quality, and there's two ways of doing that. It's either cutting it, and in WA they're lucky because, well, I don't know if they're lucky, they don't get rain later on, so they can leave it lying on the ground. And basically it's hay that's unpressed, lying on the ground, and they strip graze it on the way through. Or potentially you can use some of the herbicides on it to freeze that quality in. Yes, yeah. So absolutely, the oats themselves will. Yeah. So it's really about later on in the season, when in a sense the growing season has stopped, how well you can preserve that quality, depending on what your late season conditions are. So if it gets really wet, you can get a big mess, and I've seen that. Standing oats that have fallen over, and then all you do is get a whole lot of bloody sludge and mess at the bottom that you've got to try and deal with for next year. So it's an option.
Yeah, I've done it a couple of times with sort of young shed, and the beast harvesting and putting it in the soil and feeding back out at the same day.
Yes, yeah, and as I said, in Western Australia, that's the approach quite a number of them take. They think their secret is that they don't want to get too much rain on it when it's in that situation. So if you get a wet October, November, December, you get one of those years, it can be a bit of a mess. That's the only caveat I'd say. But otherwise, yeah, it's a technique that I've seen used and used well. Yeah. Yeah, so something I didn't, yeah. Something I didn't cover, which was around what the effect grazing has on springtime feed production. And I'll mention a bit about the grain, but irrespective of when you graze, you will reduce the amount of, well, I'll call it stubble. We might also think about it as hay or silage, depending on if that's why you're looking at it. You will reduce some of that because of your earlier grazing. Because the earlier grazing will remove some of those leaves that would naturally die off the plant, but are still there in the bulk of your plant, and it will reduce stem height. Okay, so when you graze for the first time, it will reduce stem height on that plant. So your total production at the end of the year, from a dry matter point of view, will be less as a result of it. So things like lodging, we found one of the best ways of handling lodging in our barley crops is to graze them, because you actually shorten them down and they lodge far less as a result. So big standing crops like that, oats or something like that, you can pull them down a bit by grazing earlier. So you get an early grazing off them, then lock them up after that, and would help that lodging situation.